Okay, we're on. We got the recording started. Now let me share the screen. Okay. All right, cool. So now let's get the calculator pulled up here. Okay, so you can see the calculator right on my screen?
Yes.
Okay, perfect. So probably the best thing to do is to just go, since it's recorded, we can just kind of verbally go over some of the concepts that you have. So obviously, so the way that this calculator is set up is you're going to have some basic stuff already programmed into the actual calculator itself. So if you come across a question, for instance, on calculating the, let's say the number of studs in a wall. Well, the one thing you're going to need to know is the spacing of those studs, right? And also with rebars, the same thing. If they're asking to calculate the number of rebar in a slab or studs in a wall or anything, or trees at a perimeter of a property line, anything that involves spacing, you have to make sure that you have your spacing programmed, whatever the spacing they give you is programmed into the calculator. So the way that you check these things that's programmed in is you see this recall, the RCL button. Okay, this RCL button is sort of the first step in checking what's programmed into the calculator. So let's just start with the block size. So right here above the 4, it says block size. So if we do recall 4, that tells me that what's programmed in there right now is your standard 8x16 inch block. So it's 128 square inches on the face of that block. So probably you won't ever have to change this. I don't think they're going to give you a different block size. They're going to give you a standard block size.
Okay.
So you're good with that. The other one would be the spacing. So you can see where it says above the 5, the on center. So that would be, so let's recall 5, and that tells me what's programmed in here is 16 inches.
Yes.
So if we needed to change that to, let's say 6 inches or 24 inches or whatever, if 6 inches maybe for rebar, 24 for studs.
Okay.
What we would do is whatever the spacing is, let's say it's 6 inches, I would do 6 inch and then store 5. And that, what I'm doing is storing 6 inches into that on center option. And then we can go back and we can check and make sure that it's stored it. And I would always do that, make sure that it's stored it properly, go back to recall 5, and there it is, 6 inches.
Okay.
That's pretty much as far as the storing goes, really the only things that you'll need to deal with. And I'm trying to think of anything. Yeah, I mean, you're not going to have to do any of these tread or, I mean, you can do riser heights and treads and all, but it's just, that's easy to do with just manually.
Right.
But let's see if we do recall riser height. But if you do the riser height, so if they ask you to calculate number of risers, number of treads, and they give you the distance from the top of the slab to the bottom of the stairs, based upon the riser height, you could calculate. So in this case, it's 7.5 inches is what's stored in the computer or in the calculator. So let's say that we had a 12 foot distance between the top and the bottom of the stairs. We could do, let me see. We could do, where is that button there? The tread width, there's the, haven't done the stairs, floor height, riser height, blocks. Well, I'll come back to that one with the steps, but the ones that, as far as converting those, that's easy to do manually. And then, so one of the questions that you might get is calculate the area or the number of blocks in a block wall.
Yes.
So if we have obviously you're going to probably get the dimensions off the plan. So you have to get the lineal footage of the block, see how long your wall is on the building plan. And then you're going to have to determine what the height of that wall is. Also, that'll be usually on the wall detail or in the notes, the general notes. So let's just assume that we have a 100-foot long wall by 10 foot high. So we have 100 lineal feet by 10 feet. So what you have to do, since we already have the block programmed in, the block size we want already programmed in, we just got to enter the dimensions of the wall, the 2 dimensions, the 100 feet, so 100 feet by, let's say it's a 10 feet tall wall, 10 feet. And then that's gonna give me my area of my wall. And then I'm just gonna put convert, and I'm gonna go above the length button here where it says blocks.
Mm-hmm.
And that's gonna count the number of blocks for me.
Okay.
So that's all you need to do with blocks. The other option would be for like I said, for the calculating the number of studs, is we have to take the total length of the wall, and because for the stud counts we don't need the 2 dimensions. We're just doing the lineal footage because it's going to calculate the number based upon the lineal footage and then add 1.
Okay.
So you don't have to do an area for that. Let's say it's a 100-foot wall, so kind of the same length as our block, but let's say it's 100-foot. Let me make sure, let me go to recall 5. I have 6 inches. I'm going to put 16 inches back in there.
Okay.
6-inch store 5. So recall 5, there it is, 16 inches. So I'm going to say I have 100 feet, 100 feet, and I just want to convert studs. And that's going to tell me how many studs I need a 100-foot wall.
Excellent. Yeah.
So, and then you could take, obviously, if you know you need 76 studs, and let's say the stud height's 10 feet, now you can calculate the amount of board feet based upon your total lineal footage of studs. So if I have 76 studs at 10 feet, that's 760 lineal feet of studs, right, for this wall. And so if I have 760 lineal feet, I can take 760 feet and I can convert 8, and that'll tell me, oh, sorry, I need to enter the dimension. Let's say it's 2x4 lumber, right? And I want to convert to board feet. So I'm gonna do 2-inch by 4-inch by 760 feet, and then I'm going to convert 8 because the board feet conversion is above the 8 button.
Okay, got you. Yeah, I could see it.
So that's just if you need to convert board feet. So again, if it's a 2x4 dimension, you're just going to enter the nominal dimensions of the lumber. So again, 2-inch by 4-inch by, and then 760 feet is what we came up with for just the studs, equals convert 8. And that's for the board feet conversion. Yeah. If you are doing, let's say you need to calculate the area of a circle or the circumference of a circle, they're going to give you either the radius or the diameter. So let's say they give you the radius as 20 feet, and they want you to calculate based upon that radius. They want you to calculate the area and the circumference of that circle. So the calculator is sort of already set up to take it as a diameter. So you could do one of 2 things. You could just keep it as a radius. You could do 20 feet, and then you can convert that. You can do convert, and then above the arc it says radius.
Mm-hmm.
Convert to radius. That's telling you that this is the radius. You would have to manually enter the radius, just like I did for the 20 feet.
Mm-hmm.
And then you just put circle. And then it tells you, okay, well, this is the diameter, which is 40 feet, right? That's twice the radius. And then you just keep clicking circle, and then it gives you the area. Keep clicking circle, it gives you the circumference. That's what this circumference, CIRC, that circumference gives you the total circumference of the circle. And then if you're only need a portion of the circle, let's say some of the examples we did, it was just like 1/4 of the circle.
Mm-hmm.
You would just take whatever these are. Oops, let me go back to the area. So we have this area here, but I only want 1/4 of it. I can just divide by 4, and then it'll tell me the area of just 1/4 of the circle.
And you said, why 4? Why?
Well, because sometimes they don't give you, sometimes they only give you a portion. They're asking you to calculate the area of just like 25% of the circle.
Okay.
Yeah, so it would be kind of something like this. If let me get mine. Dulack, hold on one second. I think my son took my pen. Hold on one second. Let me get my pen here. Okay, so on the exam, you might get something kind of similar to this type of question, where they give you this, it's like a right triangle here, and then maybe it's a square they give you, and then they ask you to, maybe it's a cross here, there's something there, and so they're going to label these points as like A, B, C, and D. And they want you to, maybe they want you to calculate a couple of things out of this. They could want you to calculate, let's say, the area of A, B, and C, or they could ask you to calculate distance from A to C. Something like that. So that could be an area calculation, and then you're also calculating this side diagonal, which I'll show you as well on that. So for the calculator, what we could do is, let's say we wanted to find this. Let's say we wanted to just find the area of this triangle here. Then well, you know what? We're going to do the circle first. Let me do the circle first. I'm jumping ahead of myself. Let's do the circle first. Okay. All right, so sorry, for the circle. So in this case, if you, like the same thing, if they have this kind of in this right triangle, but they're asking you to calculate this curved area. So this, again, let's say area A, B, and C. And so they want you to find the distance from A to C, and then maybe they want you to find the area of the A, B, and C. So there's two things that they're asking you for here. One is they're asking you for this distance
between A and C.
Yeah, this distance here, which is really a circumference, right?
Mm-hmm.
So this is 1/4 of a circle.
Okay.
So that's why you'd have to divide it by 4. So, and then they would give you this radius here. Let's say this radius was the 20 feet. So and they wouldn't even give you dimensions here. You wouldn't see anything here and here, because the only thing that matters here is the radius. So that's all you would need to solve this, was that 20 feet. And again, we would do, like, for that, we would do, if it's 20 feet, then we do, you could do one of two ways. Like I said, you could just do 40 feet circle, and in that way, it already, you don't have to go through this process of adding the radius. It just automatically, it defaults to the diameter.
Mm-hmm.
So if I do 40 feet circle, and then that'll calculate it for me. And that's why I divide by 4. By 4 is going to give me the area of this part here.
Got you.
And again, if I click circle again, that's going to give me, oops, because I already divided it. So 40 feet circle. So that's my area divided. I can do area and divide by 4, and then my circumference, same thing. If I divide that by 4, then that's going to tell me this distance is 31 feet 5 inches. I think it was 6 inches. There is this section just from A to C.
Mm-hmm.
So that's it for the circle part of it.
Can you do it again? That from A to C? I missed that part.
Yeah. So if you go on the calculator, you mean?
Yes.
Yeah. So okay. So A to C. Now remember, this is 1/4, right? 1/4 of a circle.
Mm-hmm.
So we're gonna do, and we know our circumference is 40 feet,
mm-hmm.
Or a diameter rather is 40 feet. That's a diameter. So I'm gonna do 40 feet circle, and then circle. So this is my total area.
Mm-hmm.
And if I do it again, this is my total circumference. Mm-hmm. So I only want 25% of the circumference, because I'm only accounting for 1/4 of the circle. And so again, you just divide by 4.
Oh, okay. So when they ask for the distance, I'm going to know that circumference that I'm looking for.
Exactly. Yeah.
Just divide it by that. Yeah. Okay. Got it.
Yep, and then if they want the area, then you're gonna have to go for the area. So, and then one of the questions that has kind of come up on a previous exam. So we're going to kind of combine a little bit of what we did with as far as the spacing and this calculating the circumference.
Mhm.
So one of the questions, so you could see a plot plan or a site plan, and let's say they have one of the corners of the property line, and they want to do a planting of some trees, right? They're going to have a tree here, they're going to have a tree here, and then they want to install trees every let's say 10 feet. So they want trees every 10 feet between this point A, and point B. And there's going to be, the circumference here is going to be, let's call it 100 feet is the diameter. This is going to be your diameter. I mean, your radius. So your radius is going to be 100 feet, and we want to know how many trees we're going to need along this perimeter, right, in order to solve the problem for them. So we can do this strictly just with the calculator. And so the first thing we have to do is we have to make sure that our spacing is programmed in properly, right? Because our spacing is going to be, in this case, every 10 feet, right?
Okay.
So if we have, we need to program in the proper spacing, and then we need to figure out the distance, right, between this point and this point.
Right.
So I'm going to first just program in, make sure we have 10 feet. So I'm going to go 10 feet, store 5. So that's going to be my on center is now at 10 feet.
Okay.
And so I want to know, now I need to figure out, okay, well, what's the distance here? So I know my radius is 100. So I can either go 100 feet, convert radius and then circle, or you can just enter 200 feet,
right,
and circle. And then, so now I know, okay, my area is for the whole circles there, but I'm not worried about area yet. I want to go straight to circumference because I'm trying to figure out this distance.
Mhm.
So I have 628 something feet.
Mhm.
But that's all the circumference, so only 1/4 of it. So I'm going to divide by 4.
Mhm.
So I'm just going to call it 157 feet.
Okay.
Let's call it 158 feet. So
Okay.
I'm going to say then this distance here is 158 feet. More is the distance from A to B.
Okay.
158 feet. So now I can go back to the calculator. And I can just do, okay, it's basically going to do the same thing I did to count my studs. And it's going to have to add 1 because I'm starting at A. I'm starting basically at 0.
Mhm.
So I have 158 feet. So 158 feet. And I want to convert studs.
So 17.
So I'm going to need 17 trees along this perimeter.
I would have guessed 20. I was guessing 20.
Right?
Okay.
Yeah, it's a little, it's kind of, with the calculator, it just makes it so much easier.
Yeah, no, this is pretty cool.
Yeah. So let's see. So that's kind of a combination of both things. Let's see. The other thing that go back to the example I was doing earlier. I got kind of ahead of myself on that, but let's take. I'm going to add another page here. Let's take that triangle example. Okay, so we have this example here where they could present this question in a couple of different ways. So I'm just going to kind of show it in 2 different ways. Actually, I don't want to do that. So we have, they could either give you a shape like a rectangle, like this, and then they could have a line going across. So this could be, again, your A, your B, your C, and your D points. And they just give you the shape with these letters. And then they ask you for the distance from A to C. And let's say they give you a couple dimensions. They say this is 125 feet and this is 200 feet. So we want to know what this distance here is, right?
Mhm.
So on the, for calculator purposes, construction purposes, this 125, this is the same thing as rise,
And then the 200 would be the run.
is 200 the run, exactly. Now, and then this on the calculator is called the diagonal, DIAG, the diagonal.
Mhm.
So if we go to the calculator, we can just easily solve this. So we know our rise is 125, so I'm going to do 125 rise,
Mhm.
and I'm going to do 200 run, and then I'm going to click diagonal, and that tells me this distance is 235.8. We'll call it 236.
Nice.
So I'm just super easy able to find my diagonal measurement. Oops. Just with the calculator.
Nice.
So I never have to do the Pythagorean theorem. I never,
Nice.
that stuff.
Yeah, that saved a lot of time.
Yeah, that's going to definitely save you time.
A lot of time.
Yep. And let's see. I mean, it does, the other, let's do the roof
Yeah.
slope calculation. That's another.
There's one with an overhang, right?
Yeah, I mean, you could get a couple of different questions. They could be just as easy as drawing. They could give you on the plan, you would see the roof layout. Just remember that the roof area extends beyond the actual exterior walls, right? So it does
Right.
include the overhang.
Right.
So you just got to be careful with that. Sometimes they just give you the dimensions to the exterior walls, and you got to find the distance of the overhang either in the wall detail or the general notes.
Okay.
So let's do one that let's just say that to my exterior wall, we have something like this. So this is exterior walls only, okay? And so they're giving you the dimensions to the exterior wall. Let's say it's 100 feet here, 50 feet here. We'll say it's 25 feet. 50 feet, 25 feet, 20 feet, and then another 50 feet here. So these are my exterior walls here. And these are my dimensions to the outside of the exterior walls. So, but my roof is going to overhang, and I'm going to say my overhang of my roof is 2 feet. So in other words, I'm going to have an overhang. I have to add an overhang of 2 feet to the entire perimeter of this roof, right? So when I'm doing my dimensions, my takeoff, I'm gonna divide this into two sections. I'm gonna divide it into a big rectangle and kind of a small rectangle. So I know that from exterior wall to exterior wall, I have 100 feet at the top. But if I want to add my overhang in, I'm going to need to add 2 feet over here. And I'm going to add 2 feet for over here. Right?
Mm-hmm.
So my total distance is going to be 104 feet from the overhangs, from the overhang here to here, all that distance, that's 104 feet. And then I also need to calculate this dimension here from this point to this point. And I know I have 50 feet. And then I have to add my 2 feet plus my 2 feet.
54.
Right, so you're gonna be 54. So you gotta add that section, so that's gonna be 54 feet. So my area of my big rectangle is gonna be 104 feet. 104 feet by 54 feet. So that's gonna be 5616, right?
Mm-hmm.
So I have 5616 square feet. This is my big rectangle.
Right, now we got to do a small area.
Right, then we're gonna do the small area. So the small area, small area, we gotta be careful because we're gonna add the overhang. So what we did was we took the big rectangle all the way through to here, right?
Mm-hmm.
So you could have done it a couple of different ways. We could have not added the overhang on this part and added it later, but you got to consider we've already kind of included this overhang for part of this roof.
Sure.
So we got to be careful with this. So we know that we had 20 feet. So let's calculate the small area. And I'm going to do the width first because the width is the easiest part. We got this and this. So we know we're at 25. So we need 25 feet plus 2 feet plus 2 feet. So that's going to be 25, 29 feet.
Yep.
Now, but this part here is a little trickier. So we got to think about, okay, we added 2 feet already. So of this 20 feet from here to here, I've already added 2 feet. I've already calculated 2 feet in the other one. So I'm at 18 feet, right?
Okay.
And then, but I need to add the 2 feet in front. So I got to add 2 feet back in. So I'm back to 20 feet.
No, so, okay, you got me on that one. So what happened now?
Yeah, so this is where it gets a little, this is where some, like a lot of times people lose the overhang
Okay.
trick, right? So this is what happens. So when we did the big rectangle, remember I added my 2 feet to the top, right?
Mm-hmm.
And I added 2 feet to the bottom.
Mm-hmm.
Well,
Oh,
when
so
I
you already accounted for it.
Exactly. I've already accounted for in the area of my big rectangle.
Okay.
For a portion of it, not all of it, but just a portion of it. So I can't double count that. So I've got to take that out that I've already counted for in the first area. So my distance from this small rectangle here, the distance is 20 feet, but I've already accounted for 2 feet of that in my big rectangle with my overhang, right?
Mm-hmm.
So I need to take that out. So now I'm left with 18 feet of just exterior wall. But then this overhang also comes down here in the front of this building. So I'm adding I have to account for my 2 feet in the front. So I have to add 2 feet back in. So I'm back to 20 feet. So the small area is going to be 29 feet by 20 feet.
Mm-hmm.
Because I have 29 feet going left and right. And then I have actually 20 feet, including my overhang for the front of the building.
Got it.
So I'm going to have 29 feet by 20. That's going to give me 580 square feet.
Yes, you just add the rest.
So yeah, so these, we're just going to add the 580 plus the 5616, and you end up with 6,196 square feet.
Okay.
This area here is called the plan area. And the reason it's called the plan area is because this does not include any slope factor. It's just plan dimensions.
Right.
Okay, so we need this plan area in order to calculate the actual area. The actual area includes the slopes. The actual area includes the slope. So we're trying to figure out the actual area of this roof. So we were able to calculate the plan area. And then we also, the last thing we need to do is we need to know the slope of this roof. I'm going to say it's a 5 and 12 roof slope. So now we have everything we need to use the calculator to calculate the actual area of this roof. So what I'm going to do, move this out of the way. So again, our plan area is 6196, right?
Yes.
Okay, so this is how you do the calculating the actual area of the roof with the slope. You're going to do 5 rise, 12 run, 6196 feet because you need to make sure it says square feet. That's telling the calculator the units.
Mm-hmm.
And then we're going to do convert roof just above the diagonal button there. Now this is telling me my actual area of my roof is 6,712 square feet.
Okay.
With that slope.
Yeah.
And I can keep pushing that diagonal button. This tells me the number of squares. And 1 square equals 100 square feet. And I can keep clicking it. The bundles you're not going to really need, but it tells you the bundles for the shingles.
That's neat.
And then this is the best part of the plywood, the 4x8 sheets of plywood you need. So you could get a question on the exam. They could really just ask you, what is the cost of the plywood for this roof. And then if they ask you that, you'd have to go through all these steps to get to that, to get to that.
That's pretty, yeah, you get 209 times whatever the cost.
Exactly. And they would give you, the cost per sheet or whatever it is. But that's it. That's how you do the roof areas.
Yeah, that's good. That's good.
So again, the tricky part on that is just if they
overhang.
Yeah, the overhangs. So
Yeah.
make sure that you include your overhangs and don't double count your overhangs.
Yeah, the overhang. Yeah, as long as I get that, should be good.
Yeah.
All right.
Yeah.
Okay. I guess the only other thing that I just had some questions.
Yeah.
But this is pretty neat. I like that little stuff we just did with the calculator. That's awesome, man.
Yeah, no, it's good. Oh, one more thing I want to show you real quick before and then we'll get on to that. But I want it with the calculator, just we can put a bow on that.
Mhm.
So the other thing on the calculator, and this is easy stuff, but so if they give you the slab, dimensions, let's say it's 50 feet by 100 feet, and then they give you the thickness, let's say it's 6 inches. So they could ask you to calculate the volume. So I want to show you how to convert this into cubic yards and also into cubic feet. So we're going to do, so 50 feet. So I got 50 feet times 100 feet times 6 inches, right? I'm going to push equals. Now my calculator automatically gives it to me in cubic yards, which is great, 92, 93 cubic yards. And if I want to know this in feet, I just go to the feet button here. Just click feet and it converts it to feet for me. I can go to inch, it converts it to inches for me. Mm-hmm. And I can just interchange between these two depending on what I need for that measurement. Mm-hmm. So yards, feet, inches, etc. So I just wanted to show you that because sometimes the calculator will just default for some reason to cubic feet.
Okay.
And people get confused as to, oh no, I need this in cubic yards. I don't know how to do it. And then you just push yards. That's it. All right.
Yeah, that's cool.
Cool. All right. What questions you got?
Okay. So I just wrote down quite a few.
Sure.
Just going over some notes. Some of the stuff I was having a hard time finding. I think I got probably like 300-400 stuff. I done learned a whole lot of stuff. So I wrote them down. Okay. Oh, the R value and U factors, the calculations on how to do those.
Yeah, so if they give you the, let's see, if you go to, let me see the energy book. So the R value and the U value, those are just inverses of each other. So if they give you an R value, it's going to be, the U value is going to be 1 over that R value. So it's just that's how you convert. But let me see if you can tab it in the energy book, just so you have it. 55. So if you have, let me see, that's the U factor. But that's the conversion. Is so if I have, let me insert my page here. So if I have an R value, let's say it's R30. Mm-hmm. So that's going to be 0.03 is going to be the U value.
So so how you just dividing?
See if I can find an example of that. So yeah, they're basically just inverses of each other mathematically.
Okay.
So so the R value, like I said, if you have the R value, if you know the R value, just the U to calculate the U value, just do 1 over the R value, whatever that number is.
1 over, okay.
And that gives you the U value.
Okay. And vice versa.
And vice versa, exactly. So if you go actually on page 144 on the of the UF book,
144.
if you look at 144 at the top, it tells you that that U factors or U values are the inverse of R values, and it gives you an example. So if you get to that type of question, you can go here and it'll tell you. So that's going to be page 144 in the UF book.
Yeah, I think I got an older version, so I'm gonna have to find it. I'll find it.
Are you in the? You're in the. Let me see. You're in. Let me just show you.
I'm in the 7th edition.
Oh, 7th. Yeah. Okay. This is the one right there.
Yeah, that's what I'm in.
Gotcha. So if you go to the index, and look under U factor. And it should be under U factor, you should see Windows.
This have an index?
Yeah, it should on the back. I don't know if you have an older one, maybe not. It should have an index at the very end.
Yeah, that'll be. Now this one don't have an index.
Oh my goodness gracious. Okay, go to let me just see if I can get you there. If you're in 144 is on mine is going to be. It's in the Windows section.
Okay.
So if you go to probably chapter, I'm assuming the chapters have to be somewhat similar. Go to chapter 7, Windows and Doors. Is your chapter 7 Windows and Doors?
Yeah.
Okay, if you go through Windows and Doors, and you'll come to you should come to a section in that says difficulties in reporting window values.
Yeah, I read over that today.
Okay, yeah. So
yeah, I see it here. I see it here.
Got it. Okay, perfect.
Okay.
Just out of curiosity, what page was that on for you?
That was page 139.
Oh my gosh. Okay. Yep. So that's a good little highlight to just show you how they calculate that U value. And I'm sure that this is also included in other parts of this book. But it's nice to just have a place to read.
Yeah. So how do you do the math though? Like I'm subtracting what? I know I'm dividing. Let me see. To get it.
Well, yeah. So basically, if I say that, so let's say that I have, the number 2. Mm-hmm. Just a random number 2. Mm-hmm. The inverse, mathematically, inverse of 2 is 1 over 2.
Okay, gotcha.
If I have 4, the inverse of 4 is 1 over 4.
Okay.
So you're just flipping them.
Okay, I'm making it harder than.
Yeah. It's just they just the technical reason why they do that is that the R value measures like one thing, and the U value like the R value measures the heat transfer, and the U value measures like the radiation transfer.
Okay.
And so they measure different things, but they're the inverse of each other.
Got it. Okay, that's cool.
That's all they do. So in this case, like the R value, if the R value is 30, then you just take 1 over the R value to get your U value, which is 0.03.
Right.
And then, so when you enter that in the calculator, you'll have your calculator here. You'll say R value is 30. Okay, perfect. I'm going to do 1 divided by 30. So you'll get that as your U value, 0.03.
Gotcha. No, that's cool. That's really good. All right. Excellent. 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 All right. See what other question I have. One other question. Let me see. Some of them I was able to find, but okay, you got that done. Okay. I think this is the last one, Chris.
Okay.
Dead load and live load.
Yeah, you want to do a quick example on that?
Yeah.
Yeah, no worries, no worries. Let's do that one. Let me just get my gear here. Okay, I'm going to do a fresh sheet here, and I'll send you this sheet just for the notes.
Okay.
They're a little scribbly. Oops, no, I want blank page. Okay, so for the live loads and the dead loads, there's just a couple of things we have to consider. So for the live load, that's going to be like the people and the furniture, etc. Right?
Mm-hmm.
So if I have a slab and I'm looking at the side view of my slab, the people and the furniture, they are putting pressure on the top of the slab only, right? So the weight of these things is just applied to this surface.
Mm-hmm.
So the way that they usually represent live loads are usually represented as pounds per square foot. Because I'm only putting pressure on the top of this slab. So it's just like a length times width. That's how you calculate live load, is going to be pounds per square foot. Now, if for dead load, is the actual weight
Of the slab, right?
Yeah, of the concrete and the rebar. So the dead load is all the stuff actually inside the slab.
Yeah.
It's all this stuff in here. So that's actually a 3-dimensional weight, because this has 3 dimensions, right? This weight of this is being applied. This is the actual slab itself. Mm-hmm. So dead loads are represented in pounds per cubic foot. So that's a pound PCF. And the difference is that pounds per square foot is pounds per square foot being applied to the top of something. Pounds per cubic foot is the weight of that something that is the pressure is being applied to.
Right.
So you need, in order to calculate your total load of what something needs to be able to support, a slab, for instance, it needs to be able to support the live load plus the dead load. It has to be designed to support that. And so during construction, what happens is while they're building these slabs, or they're forming them up, they have your slab form here. This is your slab. And then underneath, you're going to have these wooden shores usually. And these wooden shores are here to support this slab while it's being constructed and to also support it after while it's curing. So these shores are also rated to carry or to carry a certain amount of weight. So let's assume that one of these shores can carry is rated to carry 12,500 pounds. And what I want to know is I want to calculate the number of shores that I'm going to need for a particular slab. So let me see if I can enter. So for instance, let's assume, so we're gonna take this this 12,000, the shores are rated for 12,500 pounds. So if I know that each shore can handle 12,500 pounds, what ultimately do I need to know in order to solve the problem?
The slab, right?
Yeah, I need to know the total weight of this slab, dead load and live load, right? I need to know my total load. I need to calculate total load because I need that total load number so that I can make sure that my shores.
You have the right amount.
Okay, yeah, I have the right number of them, right?
Mhm.
So let's do the first step to calculate is I want to calculate my live load. So my live load, they're going to give to you, I'm going to say my live load is going to be 50 pounds per square foot. That's my live load. The second thing I need to calculate is for the total weight is going to be calculate my dead load. And I'm going to say my dead load is 150 pounds per cubic foot. They'll give that to you.
Yeah.
And then I need to calculate the total number of shores. So we're gonna presume that we have a slab that is 200 feet wide by 100 feet, and it's going to be 6 inches deep. So first thing I want to do is calculate my live load. So because I know live load is pounds per square foot, I have to calculate my weight based upon my area, my 200 by my 100, because I'm just dealing with square foot, right? Because that's what it tells me.
Yes.
So my live load is going to be in square foot. So that's going to equal 200 feet by 100 feet, which equals the area of the slab. So that should give me 20,000 square feet. And how heavy is this live load? How much are they telling me that this slab needs to support live load?
50 pounds per square feet.
Right, and how many square feet do we have?
20,000.
Right, so to calculate the total weight that I need to be able to support, I'm going to take my area, my 20,000 square feet, and I'm going to multiply that times 50. That's going to give me my total weight that this slab needs to support. So that's going to be 1,000,000 pounds.
Okay.
So that's the first part. That's just the live load, right? So we did this. Now we need to calculate the total weight of the dead load. The dead load is in cubic feet. So I need to calculate the volume of this slab. So that's going to be 200 feet by 100 feet by 6 inches, right?
You got to convert that.
Yeah, so we need to calculate that. So let's do that on the calculator here. We've got 200 feet times 100 feet times 6 inches. So this gives me in cubic yards. So now I want to go to cubic feet, right? I'm going to click feet. So I have 10,000 cubic feet,
Okay.
right? So this slab, I have 10,000 cubic feet. And then what was the weight of my dead load?
1 million.
Well, my dead load,
I
remember,
mean,
was
the
150.
dead load, sorry, is 150.
Yeah, so I need to calculate per cubic foot. I have to be able to support 150 pounds. So it's going to be 10,000 times 150, which should give me 1.5 million, I think, times 150. Yeah, so that's 1,500,000 pounds. So my total
2,500,000.
exactly, my total load is going to be what was it? 2.5 million, right?
Yeah.
2,500,000 pounds. And then how much is each of these shores rated for?
1,250.
1,250. I'm going to divide that by 1,250, 12,500.
Wow.
And so divided by 12,500. So that gives me, I need 200 shores to support this slab.
Cool. Yep, that's cool. That's awesome.
And luckily we're recording it all, so you can go back.
That is awesome.
But
Can you do one more for me?
Yeah, go ahead.
The last one to be, okay, during an excavation, you have a 130 by 90 by 20, and the operator can do 20 piles in an 8-man-hour period. How many hours would it take to complete the job?
Okay, let's do this. Hold on. Oops, sorry. Let's do. Okay, so let me write down. So we have, repeat it one more time.
130 by 90 by 20.
130 by 90 by 20. Okay.
And the 20 piles in a man-hour of 8 hours. How many days they need to complete the job?
20 piles. Is they can do 20 piles in one 8-hour day?
Yeah, I'm guessing that's the way that's what they're saying. Yeah, can't do 20 piles in a 8-hour day. Yes.
Okay, and did they give you some sort of production like
That's all I got.
was this on a question or was this like
that was a question somebody had, and I've been trying to solve it and couldn't figure it out.
Yeah, because they're gonna have to give us what they're gonna have to give us here is some sort of production in terms of
like how many they could do in a day or something like that.
Yeah, or per cubic foot. I mean, we have to like how much they could do per cubic foot. There's got to be, they're missing one thing here.
Let's just say we did it per cubic foot or whatever. However,
yeah, so let's say the production. Let's say the production is that they can excavate and put in 20. Let's say the production would be see 1,000 cubic feet. It's just hard to know what type of question they're asking. Cubic feet per, I'd have to know how they're. Well, let's just see what we get. So just solving like this. So we know we're going to have to calculate the volume. So in this case, to calculate the volume, we have 130 feet. And I'm assuming this is a shear, like a 90-degree excavation. 130 feet by 90 feet by 20 feet. So I'm going to have 234,000 cubic feet, right, of excavation. What was it, 234,000? Yeah, 234,000 cubic feet. So if I had, I guess they could tell you that you could drive, if you 20 piles in 8 man hours, they might tell you that you need, that maybe you need 1 pile per let's say 10,000 cubic feet,
Okay,
something like that.
okay,
So if they gave me this, okay, I have it now. I can solve this. So I can calculate. Okay, how many piles do I need? Well, I can take my 234
and just divide it by that.
divided by 10, right? So 234, 2,000 divided by 10,000. So that would be 234. So that's how many piles I would need. I could divide that by 20.
And that'll give you the days.
That's going to basically tell you,
Yeah, I think that was it. I think that's exactly it. That sounds like the way it was explained. That sounds like exactly it.
yeah. So in this case, you would have 11.7 man days.
Yeah, that's it.
And then if you wanted to convert that to man hours, you would just multiply that times 8. It would be 93.6 man hours.
That's it. One last question before you
Yeah.
go. Tilt up wall. What do I need to know about that? Other than that, I know it's more cost effective to build. Less training is needed when for labor.
Right.
Anything else that I need to know about it?
Yeah, I think I think on the test, one of the questions was, what is the most important thing about the tilted walls? And you need space on the slab. You have to have space on your existing slab in order to either fabricate and or lift the walls.
Okay.
So you need enough slab area to fit the walls when they're laid flat.
Right.
And then for OSHA purposes, you're going to have to, you want to make sure that you know the weights of the inserts have to hold a certain amount of weight.
Yeah, 4 times the load.
Exactly. Now there's 4 times for cast in place, and then 2 times, I think, for precast.
Yes.
Yeah.
Got him. Man, Chris, thank you very much, man.
You bet, Dulack. What time's your test?
It's Monday at 1:30. So
Monday at 1:30. All right, man. I'm going to be
opportunity.
sending you positive vibes.
Yeah, I'm going to be doing some math, probably all night tonight. I'm going to go over everything that you gave me. And then I'll probably do some tomorrow. And then Sunday, I'll probably just do some final preps. Make sure I got all my things, my tabs stapled.
Yeah.
Stuff like that. And I'll be ready. Yeah. So yeah, with the math, I just want to make sure if I could break and get at least half of them, I know I could get over this test. But
yeah.
So I think that'll help. And that's why I wanted to get with the calculator, so that way it could save me a little time. And that's been a big help, because it seemed like it's really easy. So I should be able to pick that up. I'll go over a couple of things tonight and then go from there.
Awesome, man. Well, I'll send you this recording once it's processed, and man, good luck. Call me if you need anything, and we'll get you passed, man.
All right, man. Thank you very much, Chris.
You bet, Dulack. Take care.
All right, you too. Bye.
Okay, bye.